Okay, question 9 of this paper. We're into the mechanics now, so it's getting a little bit more sort of applied. And let's give this one a go. So, a block B of weight 10 newtons lies at rest in equilibrium on a rough plane, inclined at theta to the horizontal. Horizontal force of magnitude 2, acting above a line of greatest slope, is applied to B. Part A, nice and easy. Complete the diagram to show all the forces. So I'm going to draw the diagram out a little bit bigger over here. So we've got our block B. We've got that horizontal force, 2 newtons, and we've got the angle theta. So what else do we have acting? Well, we have the weight of the block itself, and we're told the weight is 10 newtons. We have the normal reaction force, okay, which is always perpendicular to the surface. And then finally, we've got the friction, haven't we? So the friction, if we just think about which way this would fall, the block would probably fall down the plane, so friction is going to be acting upwards, and that is a nice, easy mark for us there. Okay, part B. It is given that B remains at rest and the coefficient of friction between the plane and B is 0.8. Determine the greatest possible value of tan. So, what do we need to do first? Well, we need to resolve our forces. Let's start with this one. I kind of create this right angle triangle here. This angle is theta, so we can see this is going to be 10 cos theta. This here is going to be 10 sine theta. If we do the same with the horizontal force of 2 newtons, kind of extending the triangle like this, again, this angle is theta because alternate angles, which means this force here is 2 sine theta, and this force here is 2 cos theta. Okay, this is acting to the left and up, this is acting down and to the left. Okay, what else do we know? It remains at rest, which means friction is less than or equal to mu r, and we know that mu is 0.8. Okay, so now we need to resolve in two directions. So firstly, we're going to resolve kind of parallel to the plane, and let's see what we get. So acting upwards, we've got F. Acting downwards, we've got 2 cos theta plus 10 sine theta. That's this one and this one here. Okay, resolving perpendicular to the plane, we've got the reaction force acting upwards. We've also got 2 sine theta acting upwards, and we've got 10 cos theta acting downwards. Okay, how do I know that up equals down? Well, that's because it's at rest, so there's no acceleration. Let's plug everything into my F is less than or equal to 0.8 times R now. Just rearrange this first. That's 2 sine theta. So we're going to have that 2 cos theta plus 10 sine theta is less than or equal to 0.8 multiplied by R, which is 10 cos theta minus 2 sine theta. Okay, so this is good so far. Now, let's expand out that right-hand side. So 0.8 times 10 is 8. And 0.8 times 2 is 1.6. And then 2 cos theta plus 10 sine theta. All right, what we can do now is we can bring all of the sines to one side and all of the cosines to the other. So I'm going to move this one over, and I'm going to move this one to the other side. And when we do that, we get 11.6 sine theta is less than or equal to 6 cos theta. Just remind ourselves what we're trying to prove. We're trying to find the greatest value of tan. So divide both sides by cos and both sides by 11.6. We get sine theta over cos theta is less than or equal to 6 divided by 11.6. So tan theta is less than or equal to So 6 divided by 11.6 is going to give me, let's see, 15/29. Okay, so I've got a nice inequality here. Now, what's the greatest possible value? Well, the greatest value is just going to be when this is at its maximum. So the greatest is 15/29. Okay, really hope this helps. See you for the next one.